Hi everyone, welcome to another video in our series. Now we are moving on through to one final type of function, final type of graph that we're looking at, which is what's called a cubic graph. But before we go on to that, we're just going to take a little detour to talk about solving cubic equations. So solving equations, which we've been doing for a while, but now we have a cubic element to it. We have some variable that's going to be cubed. Now let's just look and just revisit what we mean by cubing a number. So for example, doing 2 cubed, this is just a shortcut way of taking 2 times 2 times 2. Now when we do these things, we have a base. We have some kind of base number which corresponds to the number that's multiplying by itself. And we also have what we call an exponent or a power. And this exponent or power just tells us how many of the base numbers that are multiplying by one another. So here we have 3 2's all multiplying by each other. This is just a recap of what we did in indices and what we've been doing for a while. But we need to understand this idea that taking the cubing a number means just timesing it by itself 3 times. So what we wind up with here is we get the number 8 here. Because 2 times 2 gives me 4, 4 times 2 gives me 8. Now, when we cube a number, we can also do the opposite to that. So we can do like what we did with square rooting, for example. We can take what we call the cubed root of a number. So here, if you want to take the cubed root of 8, that just tells me what number multiplied by itself 3 times to give me 8. So what 3 numbers that are the same multiply to give me 8. And that's going to do the opposite of what we had up here, and that's going to give me 2. So cubing a number, taking the cubed root, those are opposite operations. In the same way squaring a number and taking the square root of a number are. So now that we have this, we're going to look at trying to solve some simple cubic equations here. Now the first one here is going to be x cubed equals to 27. Now there is a long way and a short way to do this. Taking x cubed, we're going to do this in the long way just to start off with. X cubed equals 27 is essentially asking me what is a number that multiplies by itself like so to give me 27. And we want one exact number because these are the same. Since it has the same pronumeral, these are the same number. So 3 identical numbers that multiply to give me 27. Now you can pause this video and try it yourselves, but we are going to get as a solution x equals to 3 because 3 times 3 gives me 9. Timesing another 3 to that gives me 9 times 3, which is 27. Now the quicker way to do something like this would be, and this way works, but as these get a little bit harder, we want to start introducing this thing up here, the cubed root, in order to solve these problems. Now here, I'm going to have x cubed equals to 27. Here I want to undo the cubing of this number. So I can do the opposite operation, which is taking a cubed root of both sides. This is in the same way that when we solved our quadratic equations earlier in this series and before, When we had a square number, we wanted to undo this by taking the square root. We're doing the same thing now, but we're undoing the cubing of a number by taking the cubed root. So taking the cubed root of x cubed is just the number that multiplied by itself to give us x cubed, which is going to be x here. And taking the cubed root of 27, you can find this in your calculators and plug it in. That's going to give you 3 here. So that's how we would approach something using this slightly simpler method. And this simpler method is going to be useful when we get to some trickier ones, which we'll see in the next couple of examples. So, for example 2, we're trying to find the value of x here for minus 2x cubed equals to 16. So like with the previous example, we want to strip away to get to x here. So that means we need to start thinking about getting rid of all these things attached to x. The negative 2 that's multiplying by it, and the cubed that's getting applied to it as well. So we're going to do this by systematically stripping away to get us to x. So here my negative 2 is multiplying by x here. So I can divide both sides by negative 2 in order to cancel out that coefficient, that number in front of x cubed. And that gives me negative 2 divided by negative 2 just gives me 1. They cancel out. So I just get x cubed here equals to negative 8. And now I have something in the same form as I did up the top, which I can undo quite easily by taking the cubed root. So I'm taking the cubed root of x cubed and the cubed root of negative 8. Taking the cubed root of x cubed gives me just x on its own, and cubed root of 8 just means what is just finding what that number is that times by itself. Once, twice, and then a third time. So we're looking for 3 numbers that are all the same that multiply to give me negative 8. You can put this in your calculators as well, but this is going to be minus 2. Because minus 2 times minus 2 gives me positive 4 because we have a double negative, and multiplying another negative 2 to this gives me negative 8. And you can also just pop this into your calculator, taking the cubed root of negative 8. That's going to give you the answer here. Now we're going to do one more question to wrap up here. We want to find the value of x that satisfies this equation, 3x cubed plus 10 equals to 193. And we want to get our answer to 1 decimal place, because this won't be a nice answer here. Okay, now the same thing here. It's going to look scary and extensive, but we're just doing the same thing we did with regular equations. We're trying to chip away the numbers that are being applied to my x cubed, and then I want to take the cubed root to get me to x. So the very last thing that was done to the x here is that, well, it was cubed, then it was multiplied by 3, and then 10 was added to that. So 10 was added last, so I want to undo that thing here to slowly get me back to x here. Now these two cancel out, leaving me with 3x cubed on the left, and then on the right hand side we get 183. Now I want to isolate my x cubed. Now 3 here is multiplying by x cubed, so I want to divide it here to undo this multiplication of 3. So I want to divide both sides by 3. That gives me x cubed on its own here, and I get 61 on the right hand side. And now that I get to this step, it just becomes the same thing that we did right at the very start, which is once we have something in this form, I can always just take the cubed root of both sides to get me the value of x. And taking the cubed root of 61, that gives us a messy number, so we're going to just round that to 3.9. So in approaching each of these equations, we always, no matter how scary it got, we always tried to get back to this particular point, stripping away things from the x cubed to give me something in this form. X cubed equals something on the right hand side. And then we took the cubed root of both sides. No matter what difficulty our question was, the second last step was always getting it to this form, where we can apply our cubed root and find an answer. Now with this first question, that was just our very first step because it was a more basic one. But every single time when we approach solving cubic equations, we are just doing them in the same way we would with regular equations questions. We're stripping away the things that are around x to isolate it. But now we're not just isolating x, we are isolating x cubed. Once we get it to this in this form, we can just take a cubed root to just undo the cubing to get us to x on its own.